What if I told you that you could make your Python classes super safe? That you could stop someone or even yourself from accidentally setting a bank account balance to a negative number or a user age to 500. This isn't just about writing lots of check everywhere code. It's about a powerful, clean and simple Python feature that pro developers use. So this is day 3 of our object-oriented programming in Python series, and today we are diving into one of the most important ideas of object-oriented programming, which is encapsulation and the property decorator. Alright, let's make encapsulation simple. Think of a class like a safe box. Inside this box, you have your data. We call these attributes, and the functions that can work with that data. We call these methods. Encapsulation is the idea of bundling your data and the functions that use it together and protecting that data from being changed by accident. Why is this important? Imagine a bank account class. It has a balance attribute. If anyone from anywhere in your code can just write myaccount.balance equal to -1000, that would be a huge problem, right? You can't have a negative balance. Encapsulation helps us build a safe wall around our data, so it can only be changed through methods we approve. In other languages like Java, you use special words like public or private to force this protection. Python is different. Its idea is we are all responsible programmers here. It uses special names as hints to other developers. Let's look at them. We'll define a simple class customer, the def double underscore init underscore method with parameters name and age sets our object with the name and age. Since self.name and self.age don't have any underscores, they are public attributes. We can create a customer object C1 and freely we can print its name, and when we run it, it will output ls. Interestingly, we can also change C1.name directly to any value, say Alan, and if we again print C1.name and run it, it will show Alan on the output. This is what public means, open for everyone to read and change. Now, what if you want to signal that an attribute shouldn't be changed from outside the class? You use single underscore at the beginning, like underscore balance. We call this protected. Okay, so here is our bank account class, and notice that underscore balance starts with one underscore. This makes it a protected attribute. So now we'll create a bank account class for a customer Bob with a balance 1000, and when we print account owner, it will print Bob. What happens if we print acc dot underscore balance? When we run it, we can still access underscore balance. And what if we change this protected attribute to -500 and print its value again? Wow, we can even change it to a negative number. Python doesn't stop us, so you can still access it, but you shouldn't. The single underscore is just a hint to the programmer or other programmers that says, hey, this is meant for the class own use only. Please don't touch this from the outside. It's a friendly agreement, and modifying it is a bad practice. Okay, but what is if you really want to discourage people from touching an attribute? That's where double underscore comes in, like double underscore transaction underscore ID. This is considered private. Python does a clever trick here called name mangling. So let's add another attribute in our bank account class. The attribute transaction underscore ID has 2 underscore, making it private. When we create a account and try to access double underscore transaction ID and print it, it will give an attribute error. It says that the object has no attribute named double underscore transaction underscore ID. It seems like it's completely hidden. So is it truly hidden? Not really. Python has just renamed it to stop you from using it by mistake. It mangles the name by adding underscore class name to the front. So here is the secret. Python actually renamed it behind the scene to underscore bank account underscore transaction ID. So if I use a full Mangle name and run it, it will work. This shows it's not for security. It's a strong warning to prevent you from using it and to avoid naming conflicts. So to review, public attributes have simple name and anyone can use it. Protected attributes have a single underscore preceded before the name and it's intended for internal use only. Private attribute has double underscore name and they give a strong warning to avoid its usage. So how should we safely work with protected attributes? In other languages, you can create get and set methods. Python has a much cooler way, the @property decorator. A decorator is a tool that gives a function extra powers. The @property decorator lets us make a method that acts like a read-only variable. It's super clean. Let's see the code. So we'll start with our basic bank account class and we define a class method balance, which is a getter for the balance. I've given a print statement getting a balance via @property decorator and it's returning the underscore balance attribute from the object. Now I'll add @property decorator at the top of the method balance. So when we add this property attribute, this method's job is to now return the value of our protected underscore balance attribute. Let's create a simple account object with name if and balance 3000 and if I'll print acc.balance and run it, we'll get the account balance, which is stored in double underscore balance attribute. Notice that there's no parenthesis after balance. It looks like we are accessing a variable, but Python is secretly calling a balance method. So let's see what if I tried to set balance value to something new. And if I run it, we get an error because by default, the property balance of the bank account has no setter. Right now, it's a read-only property. So this is the other half of the puzzle. We can create a matching setter for our property. You write it as a @ then property name over here is balance and then dot setter. So now let's add setter to the class. We add our setter underscore balance dot setter decorator. We define another method also named as balance, which takes amount also, and this is our setter. Inside, I have written a print statement to show at the console that setter is being called, and we have our safety check that if amount is less than 0, then we'll raise a value error exception which passes the text balance cannot be negated. And if its amount is greater than 0, we assign balance a new amount. Now, after this method, we run it and we see that we get no error. And if I print count.balance again, its value has been changed. So the setter has been called and its value has been changed from 3000 to 3500 and I've printed the 3500 amount. Now there is one catch or a gotcha that you need to be aware of. So what if I assign negative balance in the constructor? What would happen? Will setter be called? And the answer is no, because the constructor has set the account balance to negative value. Setter is called when we're accessing account.balance and assigning it to amount, whether it's negative or positive. But setter is not getting called when the constructor is being called and we by mistake pass a negative value to the balance parameter. To rectify this mistake, we'll just replace underscore balance with balance. So this now will automatically call our setter when we first create the object. And let's check this. Now we run it and we get the error setter called and we get the error balance cannot be negative. And if I change it to the positive, then also you can see in the constructor, when the constructor is called, the setter is called. This is the Pythonic way of setting and getting the attribute value. So in Python, instead of using getters and setter method, we can directly define a attribute value with the help of property decorator, which can get and set the value of an attribute. The property decorator is also amazing for calculating attributes, properties that don't store a value but figure it out whenever you ask for it. So let's see an example. So I'll clean the file. Here is a user class with attribute first name and last name, which are set in constructor of the user class. Here we create a property full name, and it doesn't store anything. It just combines first name and last name and print it whenever it's called. So when we create a user and ask for user.fullname, it gives us the combined name. Let's see with an example. So over here we have defined a user object which is initialized with user class constructor with the name Grace as first name and the last name as Hopper. And what if I'll call print on user.fullname? When we run it, we'll see it's printing Grace Hopper. This full name attribute does not exist as an attribute in the object attribute list or a set of object attributes, but it's a calculated attribute using property decorator, which is very useful. And the best part, if we change username, let's say to Edda, and will print the full name, it will proper full name, the property automatically update the next time we ask for it. Alright, that was a lot. So let's go over the main points. Encapsulation is all about keeping your data safe. It's the idea of packaging your data and methods together in a safe box to protect your data from bad changes. Python naming hints are a single underscore is a friendly hint that says please don't touch from outside. A double underscore is a stronger warning that also renames the attribute to make it harder to use. The property decorator lets you make a method that acts like a read-only variable. It's clean and easy to read. The setter gives you a safe place to check any new value before you update your data, making your classes strong and reliable. The calculated properties are dynamic attributes which are not stored and gives you always a fresh value based upon the changes that you have done by calling getters or setter method. You have just learned one of the most powerful feature in Python for writing professional level classes. You're not just creating classes anymore, you are designing them smartly. If this video helped you understand encapsulation, please hit the like button. It really helps us the channel grow. Don't forget to subscribe and hit the bell so you don't miss the next episode where we will be talking about class methods, static methods and composition. Thanks for watching Sumantra Codes. Keep learning, keep building, and I'll see you in the next one.